Okay, so let's take a look at number 3 on your collisions problem homework. So we have a 2,575 kilogram van runs into the back of an 825 kilogram compact car, which is initially at rest. They move off together at plus or positive 8.5 meters per second. Assuming that the friction with the road is negligible, calculate the initial speed of the van. So we are dealing with momentum conservation. So let's organize our information and what we know. Okay. So we can say van and car, and we're looking at everything that we know about it. So we know that the mass of the van, we are trying to figure out the initial velocity. So we're kind of working backwards. So we don't know that, which also means that we actually don't have that value either. We're going to need to have that value. For the car, we have the mass is 825 kilograms. We have that its initial velocity is 0 because it's at rest, and that makes its momentum before the collision 0. These two need to add up to be the total before. So this is all before the collision. Now, what about the collision that's going to be helpful to us? So let's divide it again. So let's look at what happens after. So after the collision, we still have the mass of the van, and we have the mass of the car. They stick together because it's an inelastic collision. So they will have the same momentum and they will have the same velocity together. So that's going to make it much easier for us to figure out. Okay? Because if we can figure out what we have the final velocity actually that they move off together with, and we're trying to really get this information, because if we can find this out, then that's going to be the same as that, and if we have that, we can get this, which is really what the question's asking. Okay, so it's not a scary problem. It's actually very simple, but just backwards from what you saw in class today. So P equals m times v, but it's the m total times the final velocity of the two automobiles together. So I'll write it on here. So P equals these two masses times positive 8.5 meters per second. So the momentum is going to be a positive 28,900 kilograms centimeter over second. So we use that here because this is initially 0. If this is their momentum together afterwards, then that has to be their total before. So the total P before has to also be this value. And because this is 0, all of the momentum of the system initially was with the van, because the van was the one thing that was moving. So let's take away our question mark, because it's no longer a question mark. We know what this is. And now we can find V fairly easily, right? V equals P over M. So if we plug in our values, we're going to get V. So we're going to take this question mark out because we know what it is. It's going to be a positive 11.22 meters per second. And now we have officially answered the question.